Here, says in the figure, XP and XP are tangent. Angles ATX equals alpha and angles APX equals beta. Prove that BTXP is a cyclic quadrilateral. To prove it, first I use the theorem that says angle between tangent and a chord. So I use this rule here which says I have a tangent here xp and a chord that makes beta. So if I subtend a chord with the alternate segment, this angle B, PBA, so angle PBA would be beta. I use this, sorry, would be beta angles PBA. Now I will go for the next tangent TX and chord make alpha. So if I subtend the chord with the alternate segment, here it would be, write it beta, it would be alpha. So I use the same theorem and write TBA, this time TBA equals alpha. So the angle CBA equals alpha. Now I know if I add them up, it would be TBP, which is alpha plus beta. It's my step one. So I prove TBP equals alpha plus beta. I will go for a step two. For step two, I consider the triangle TXP. For in triangle TXP, we know the sum of the interior angles of any triangles add up to 180. I have alpha, beta, two angles of this triangle, so I only have to find the angles TXP, the angles TXP equals 180 minus alpha minus beta. So I factor negative sign, so I have to write minus alpha plus beta. It's a step two. Now I use the rule that says if for any quadrilateral, if two opposite angles add up to 180 or they are supplementary to each other, I say this quadrilateral is cyclic quadrilateral. So I add up these angles and these angles together to see there will be 180 or not. So I will from step 1 and 2, step 1 and 2, when I add up this angle PBT, or I get from here TBT, TBP, plus txp txp. I substitute any expression that I get from step 1 and step 2. Instead of TBP, I put alpha plus beta, alpha plus beta. And from step 2, instead of TXP, I put 180 minus alpha plus beta. Now I undo this alpha plus beta with negative alpha plus beta, so I will have 180. Now I write, we prove this quadrilateral is cyclic quadrilateral because a pair of two opposite angles is supplementary. Supplementary. Where I can't write? Supplementary. Okay. So I could prove. Sorry. I have to correct it. Prove. I don't know why it makes mistake to type. This quadrilateral cyclic quadrilateral because a pair of two opposite angles is supplementary, and add up 280. So I prove it. I will go for part B. For part B, says shows that alpha equals beta. To show this that alpha equals beta, I use the rule of cyclic quadrilateral. It says if two angles subtended to one side of cyclic quadrilateral, so these two angles from the opposite vertex are equal. So I will write it for any cyclic quadrilateral if two angles and angles from of two other vertices subtended to one side of this cyclic, they are equal. So I use this rule. So I say for base, so for base, I have to say for side XP, for side XP, these angles and these angles from the other vertices subtended to this side. So XP, two angles PBX, and PTX and PTX of two other vertices, two other vertices subtended to XP, so PBX equals PTX. That means beta equals alpha. Sorry, let me correct it. It says two angles. Let me write two angles. So I could prove beta and alpha are equals. I go for part C. For part C, I am gonna show that these angles and these angles are equal. That means TP, it's a show that PT bisect CTX, CTX. So to prove it, I show that now for part C, I account for this quadrilateral BCTA that described the circle. Here, I say the angle A and angle C angles A and angle C subtended to cover the complete arc of a circle. So I can say if I get angles BAT, angles BAT, which is circumference angle plus angles BCT, BCT. So we know they add up 180 because this angle subtended to this arc TB, and angle BAT subtended to this arc. That means split circle to arc that cover 360. So this angle add up to 180. Now I say it's a cyclic quadrilateral. So this angle and this angle should be add up to 180 as well. This angle, as we know here, we have a straight line, so this angle would be 180 minus alpha plus beta. We know alpha plus beta are same, so minus 2 alpha. This angle would be this angle would be 180 minus 2 alpha. Now I change my color and write the angles. So angles A, B, C, A, B, C plus angles C, T, A should add up to 180 because it's cyclic quadrilateral. So ABC is 180 minus 2 alpha plus alpha, which gives me 180 minus 2 alpha this part, and alpha, which gives me angles ABC plus alpha plus the angle CTA equals 180. I can cancel out this 180 and 180 undo with each other, because if I bring 180 in the right side becomes negative 180, and here I have alpha plus negative 2 alpha, which gives me negative alpha. Now I bring negative alpha to the right side, so CTA, the angle CTA equals alpha. I could prove CTA equals alpha. So CTA equals ATX. So CTA equals ATX equals alpha. That means, so I can say TA or TP, if I continue subtend this line, so I prove TP is a bisector of angles CTX, is bisector of angle 3tx.